In this lesson, we are going to continue with our vector operations. It's asking us to calculate and sketch the unit vector u, which equals cosine of theta I plus sine of theta j, for theta, which is 2 pi over 3, and include the unit circle in your sketch. Let's first start and review about what it means. So I'm going to first take and draw our unit circle. Okay. We have a point on the circle, which we know is cosine of theta, sine of theta. We have our reference triangle here. So from the origin to the right, we would say that this is cosine of theta, or our I value, and going up would be sine of theta, or j, with theta being here, and u is equal to our distance. All right, well, if I know what theta is, I can go ahead and take theta and plug it in for each location, such that u would be cosine of 2 pi over 3i plus sine of 2 pi over 3j. Looking at our unit circle, then, I can identify that cosine of 2/3 pi, looking around our unit circle, is equal to negative half I. And I know that sine of 2/3 pi on our unit circle is the square root of 3 over 2j. And now we want to sketch this vector. We had our general idea as a reminder, and now using our vector ideas, we can start at our origin and find our point on the unit circle, where we would have negative half I and the point square root 3 over 2j. Where from here to here would be u, and from here to here is our theta, and our theta being 2 pi over 3. Our next example is to determine the direction angle theta of our vector w when we have negative 4i minus 3j. We know that this is the same written in component form of negative 4, negative 3. What I can do is draw an idea of where this would be located. This is going to end up being in our third quadrant. When I go to the left, negative 4, and I go down negative 3, creating our reference triangle. What I'm given, if I need to find what theta is, what I'm given is tangent, since tangent is opposite over adjacent. So opposite is negative 3, adjacent is negative 4, or 3/4. I'm looking for a degree value of theta because I ultimately want to know what is the degree from here all the way to this location. So to do that, I need to find the inverse of tangent. So what degree value of inverse of tangent would give me 3/4? When I calculate that using my calculator, I get approximately 37 degrees. We know that this is in the third quadrant, and theta in the third quadrant with its reference angle would give us 37 degrees, which was our theta reference triangle here, plus 180 degrees, or 217 degrees. We can also find the dot product of two vectors written in component form. Notice when I'm finding the dot product of both of them, I'm taking our first u and our first v, multiplying and adding it to the second u and the second v. This is scalar and not vector. Okay, so find the indicated dot product when I have three different values or vectors in component form. I want to find u dot w. So to do that, I'm going to look at u and my w. So I'll take 2 times -3 plus -5 times 1. Simplifying gives us -6 minus 5, or -11. Part B is asking us to find w dot v. So this time I'm going to do v and w. Taking 0 times -3, adding that to 4 times 1 gives us 4. And I have a little note here that because we know multiplication is commutative, it doesn't matter the order in which we multiply. We can multiply w dot v or v dot w and end up with the same result. We also can find the angle between two vectors. This is finding the smallest positive angle form by two directed line segments. So to find the angle between two vectors, if theta is an angle between two non-zero vectors u and v, then we can find the angle by taking cosine of theta, which is equal to u times v over the magnitude of u times the magnitude of v. So recall, when I have vectors in here, we're looking for the magnitude. So find the angle between u and v written in component form. Well, we first need to find u dot v multiplied by u and v. So we'll first take 3 times -4 and 7 times 2, resulting in +2. We then need to find the magnitude of u and the magnitude of v. The magnitude of u will give us 3 squared plus 7 squared, or the square root of 58. The magnitude of v will give us -4 squared plus 2 squared, or 16 plus 4, which is 20. Writing this using our cosine of theta, u dot v we found was 2, and then we have the magnitude of each. Well, if we're looking at finding what is theta here, the angle, we need to find cosine inverse of all of this. So when I plug into our calculator, cosine inverse of all of this will give us 86.6 degrees. A 350-pound block is suspended by 2 cables as shown below. At point A, there are 3 forces which are acting on this. W is the block pulling down itself, and R and S are the 2 cables pulling up and out respectively. Let's find the tension in each cable. So what's happening is we have this block here, and it's being suspended by these cables. In order for there to be balance, the vector sum must be the vector 0. So when I add all of the vectors together, it must be balanced and equal 0. We can express each vector in terms of its magnitude and the direction in which it's going. So we can refer to each vector R can be referred to its magnitude times its directional angle. And its directional angle for R is cosine 125 degrees I plus sine of 125 degrees J. Similarly, we can do for S, its magnitude times cosine of 37 degrees I plus sine of 37 degrees J. And then W itself, the magnitude of W of cosine 270 degrees I plus sine of 270 degrees J. We know what W is because it's 350 pounds. So its magnitude, we know already, is 350. I also know that cosine of 270 is 0. And I know that sine of 270 is -1 based on our unit circle. So when I have 0I minus 1j, altogether when I distribute would give me -350j. We know then that to have an equilibrium, the 0 vector is 0I, 0j, since we're not going left or right, nor up and down. That will then give us our R values plus our S values I, combining like terms when I'm starting to add these values together. Now adding my J values together, we have the magnitude of R times sine of 125 degrees plus the magnitude of sine, S times sine 37 degrees minus 350j. All of this has to equal 0I plus 0j for it to balance out. This then will give us two different equations. It will give us the magnitude of R cosine of 125 degrees value here equal to 0. And then it also gives us the equation with our J values equal to 0. We can solve our first equation for R. When we solve our first equation for R, we see that the magnitude of R is negative magnitude of S cosine of 37 degrees over cosine of 125 degrees. But now that I know what R is, I can substitute this R value in for here such that we can solve for the magnitude of S. If we then solve for the magnitude of S, then substituting it in, we'll have the negative magnitude of S cosine of 37 degrees over cosine of 125 degrees times the sine of 125 degrees plus this next piece, this now equals 0. What we can do then is add 350 to both sides and then isolate, because I can factor out this portion here. So if I factor out the magnitude of S, I'm then left with negative cosine of 37 degrees over cosine of 125 degrees times sine of 125 degrees plus sine of 37 degrees equals 350. This here is just going to give us a decimal, so I could get the magnitude by itself. When I solve for my decimal, I see I have 1.74, which is the decimal of all of that, giving me the magnitude of S once I divide both sides by 1.74 again, which is just the decimal of all those sines and cosines, gives me about 201 pounds. Well, now that I know what the magnitude of S is, I can solve for the magnitude of R by plugging in the magnitude of S. So negative 201 times cosine of 37 degrees over cosine of 125 degrees. That will then solve for me the magnitude of R, and the magnitude of R gives me approximately 280 pounds. Let's review here. So R, we determined the magnitude of R. So the length of R we found is 280 pounds. And 280 pounds. And the tension, or the magnitude of S, we found was 201 pounds. So to finish this, the tension on the cable on the left, which was R, was 280 pounds. And the tension in the cable on the right, which was S, is 201 pounds.